Let's take a look at our warm-up problems for this unit. Let's start with the first one, 5p equals 2.5. I'm going to go ahead and divide both sides by 5. That's going to give me just p. And 2.5 is kind of like 25, and I know 25 divided by 5 is 5. So if I take 2.5 and divide it by 5, I'll just get, oops, hit the wrong digit. I'll just get 5/10. Okay, so p would equal 5/10. On to number 2. 1/3 of j equals 9. So what I'm going to have to do is I'm going to have to multiply both sides by 1/3, or by 3, sorry, in order to get this 1/3 to 1. 3 times 1/3 is 1 times j, which is just j. 9 times 3 is 27, so j must equal 27. When I plug it back in, it works. If I take 1/3 of 27, I get 9. Here's a problem. 0.12 or 12/100ths k equals 10.08. In order to get k by itself, I have to divide 10.08 by 12. Now, I know that this number is going to be bigger than 10.8 when I'm done, because when I divide by something less than 1, I'm going to get a bigger number, because it's basically asking me if 12/100ths is 12%. It's saying, what number can I take 12% and get 10.08? So I'm going to get a bigger number here. This is a great opportunity for us to practice our long division. So I'm going to go ahead and take 10.08, divide it by 0.12. Okay, I have to do this though, right? I have to get these decimal points over and equal so that I can use the whole numbers. Now, does 12 go into 1? No. Does 12 go into 10? No. So I have 0 and 0 here. Does 12 go into 100? Yes, 8 times. 8 times 12 is 96, and I have 4 left over. I drop my 8. Now, how many 12s are there in 48? 4. The decimal point's all the way over here, so the answer is 84. K equals 84. It's always good to practice our long division. 8 times k equals 0. Well, to get 0 as a product, you have to have multiply something by 0. So k has to equal 0, because if I divide both sides by 8, I still get 0, and there we go. Now, on to the big part of the lesson. We have to come up with some equations. Now, we know that there is 1/4 the number of nickels that there are dimes. So the number of nickels and dimes would be n equals 1/4 the number of dimes. We could also write this as dimes equals 4 times n. And that is the relationship. These are our constants of proportionality. That's the answer to question 2. When you find the relationship between the two and it's proportional or multiplicative, this is going to be our constants of proportionality. The number of dimes to the total number of coins. Okay, so if I have a total number of coins, right, I know that 4 out of every 5 coins is going to be dimes. So total number of coins equals 4/5 times the number of dimes, which means that if I have nickels to total number of coins, t equals 1/5 of, I'm sorry, oops. 4/5 of the total number of coins equals the dimes, and 1/5 of the total number of coins equals the nickels, right? Because if we have pile of 5 coins, 4 of them are going to be dimes, 1's going to be a nickel. And then identify the constant of proportionality in each proportional relationship described in 2. So we're just going to go ahead and use the coefficients. That is the constant of proportionality. And if we have this set up, it's always going to be the same. So you could use 1/4 or 4, depending on what you're solving for. Okay. In terms of dimes and total coins, it'd be 4/5. In terms of nickels and total coins, it'd be 1/5. So you could have 1/4 or 4 for A. B would be 4/5. C would be 1/5. Hopefully that was helpful. Bring your questions to office.